Hello, welcome back to Proximity Math. I'm going to go over the 2005 Aime Ii number 6. Okay. The cards in a stack of 2 end cards are consecutively numbered from 1 through 2n from top to bottom. So we have our cards here. We have 1 until 2n. Alright. The top n cards are removed, kept in order, and form pile A. The remaining ones form pile B. So we have 2 stacks now. We have, I'm sorry for the bad drawing. So we have 1 through n in stack A, and then stack B is cards. It starts n plus 1, and then it goes to 2n. Alright. The cards are then restacked by taking cards alternatively from the tops of pile B and A, respectively. So take the top one from B, and then the top one from A, and so on, just like that. In this process, the card number n plus 1 becomes the bottom card of the new stack, obviously. So the first card picked is n plus 1. Okay, card number 1 is on the top of this card, and so on, until piles A and B are exhausted. Okay, exhausted. If after the restacking process, at least one card occupies from each pile occupies the same position, if at least one card from each pile occupies the same position that it occupies in the original stack, the stack is named magical. Find the number of cards of the magical stack in which 131 retains its original position. Alright. So if after the restacking position, at least one from each pile or anyway, so the way to go about this is probably to form an equation which gives you the new position of a card, and then we can equate that with its original index and then set that number to 131. You'll see what I mean. Alright. So when we restack, it's n plus 1, 1, n plus 2, 2, and so on. And you can easily notice the card right below is n more than the card right above. They come in pairs. So it's n plus 2, and then if you subtract n, you get 2. All the way until we take 2n and then n. Alright. So 131 is its original position. Okay. Let's see here. Okay, first of all, we will notice every even card starting from the bottom. Is that a good idea? No, it goes backwards from the top, so we can start from the top. Okay. This one is from pile A. Is it? Yeah. So as you can see, the first card is from pile A, then B, and so on. It goes A B A B. So every odd number card in the new pile from the top is from A, and every even card is from B. Not the number even, but like this is the first card, this is the second card, and so on. So if this was a 53rd card, for example, 1 was a 53rd card. Yeah, that's true. 1 is from pile A. So like that means it would be from pile A. Anyway, so now that we have that information, If 131, which is odd, retains its original position, and I'm gonna count not from the bottom, but instead from the top, because that's the original counting. So the 131st card from the top is an odd number from the top, which means it's in pile A. And if it's in pile A, it must be, so 131 is less or equal to n, clearly, because otherwise it would fall in pile B, which is from after n to 2n. See? Okay. Next, okay. So, okay, let's see here. Okay, so the first card in the new pile, the first one is gonna be n. The third one is gonna be n plus, sorry, n minus 1. The fifth one is gonna be n minus 2, and so on until the we have 2n cards in total. So the 2n minus 1, 2n minus 1, position 1 would be 1. Okay, we don't really need that, but anyway. So in general, you can find that pattern that the n minus k card is in position. So the n minus kth card is in position 2k minus 1. Wait, let me test. 2k plus 1. Okay. Like for example, if k is 2, then 2 times 2 plus 1 is the fifth position. Okay. So you can easily find that pattern. And then using this, 131. So if we want 131 is equal to this, that means k would equal n minus 131. So that gives us the position being 2 times n minus 131 plus 1. Because if we let k be n minus 131, then n minus k is just 131. So our card is in this position in the new stack. And the old stack has just position 131. So by equating these positions, it would have the same position in both the old stack and the new stack. It retains its original position, see? Alright. Okay. So we get 130. And then divide out the 2, we get minus 131 equals 65. And therefore, we get n as a final answer of 196. Is it? Oh, but wait. Do not downfall there. It's asking the number of cards, which is not n, but 2n. That's the total number of cards. So the total number of cards, which isn't n, it's 2n, is equal to twice this, which is 392. Alright, thanks for watching, and I hope this helped you.